Module 1.10, Introduction to the Oscilloscope. As we've mentioned before, sound travels in waves. In order to study waves, it will be helpful to be able to observe them. One of the ways we will do that is by using an oscilloscope. An oscilloscope is a device that allows us to observe waveforms in real time. Modern oscilloscopes allow you to store and print out waveforms. Before we learn how to hook up an oscilloscope, let's see how we can measure waveforms on an oscilloscope screen. Oscilloscope screens have a grid on them. The vertical part of the grid, the y-axis, allows us to measure the voltage of an electrical signal, and the horizontal x-axis indicates time. Knobs on the front panel allow you to adjust how the waveform is displayed on the screen. The large vertical scale knob adjusts the number of volts per division, allowing you to increase or reduce the height of the waveform so you can see it clearly. The screen indicates the values for each division. In this picture, that info is on the bottom left where it says channel 1 equals 500 millivolts, meaning each vertical marking represents 500 millivolts. Each of the little dots or subdivisions represents 2/10 of a division. So this sine wave is 2.4 divisions tall and 5.6 divisions wide. The large horizontal scale knob adjusts the amount of time that each division represents. This allows you to condense or spread out the waveform from left to right. The time value appears on the bottom of the screen, just left of center. The picture shows the time value as 100 microseconds, which means each horizontal division represents 100 microseconds. In other words, it takes 100 microseconds to travel one division on the screen. So looking at the picture, we see two cycles of a sine wave. The wave height is 3 divisions above and 3 divisions below the center line. So the amplitude or voltage of the sine wave is 3 divisions plus 3 divisions equals 6 divisions times 500 millivolts per division equals 3000 millivolts or 3 volts peak to peak. The length of one cycle of the waveform is 5 divisions from left to right, so the period would be 5 divisions times 100 microseconds per division equals 500 microseconds. If you know the period, you can calculate the frequency using the equation F equals 1 over t. So the frequency of the sine wave would be 1 over 500 times 10 to the minus 6 seconds equals 2000 hertz. The smaller knobs above these controls allow you to adjust the position of the waveform on the screen. You'll want to do this to make measuring the waveform easier. Turning the large knob allows you to zoom in and out to see more or less of the waveform on the screen. Important note: the knobs only change the way the waveform is displayed on the screen. It does not change the value of the amplitude or the period of the waveform. Also, to get the greatest accuracy when making measurements, adjust the knobs so that just 1 or 2 periods of the wave are on the screen. This is what I will want to see in screenshots that you take. In this class, when measuring amplitude, we will use the value called peak voltage, or V0, which is the peak-to-peak voltage divided by 2. If the waveform is symmetric above and below the center line, then V0 is simply the positive portion of the waveform. So, in the above picture, the amplitude would be 1500 millivolts, or 1.5 volts. Now that you know how to find the amplitude and period on the screen, let's look at how to actually operate the oscilloscope. Although there are many buttons and knobs on the scope, we will only use a few of them. We already spoke about the vertical and horizontal scale knobs, as well as the position knobs. To turn on the scope, you'll push the power button. If the scope doesn't turn on, check that the power cord is all the way in and plugged into an outlet. Once the scope is on, press the default setup button. The function buttons on the side of the screen will occasionally be used. When they become active, their purpose will be displayed with a menu on the right side of the screen. Underneath the function buttons is a circular button that turns the menu on and off. Turn off the menu when taking screenshots on the scope. When you are displaying a waveform, sometimes it will be jittery. In order to make it stand still, press the Trigger Menu button. That will present you with a menu of options that will stabilize the waveform. The most common fix is to turn on high frequency rejection or noise rejection. Press the Trigger menu, More, press Coupling, and then select Noise Reject. If that doesn't work, try HF Reject. I will have large pieces of paper to remind you how to do this. You will use the Channel 1 input to connect different devices to the oscilloscope. It uses a BNC type connector for the input signals. To make screenshots, you'll use a flash drive. Plug it into the USB port on the bottom right of the display and press the Save button. Finally, pressing the Auto Set button will often set up the screen to give you a good initial view of the waveform. In this lab, you're going to hook up a sine wave generator to the oscilloscope and measure the amplitude and period of sine waves with different frequencies. You'll compare the measurements you made on the oscilloscope with measurements you take from the sine wave generator and the voltmeter. The purpose of this lab is to give you experience using the oscilloscope and to determine whether it is an accurate device for measuring amplitude and frequency. To determine the accuracy, you'll calculate the percent difference between your two values with this formula: difference over average times 100. In other words, the absolute value of the measured minus the calculated values over the measured plus the calculated values divided by 2, all times 100. You'll be making this calculation for many of the labs. In this course, the percent difference should be less than 10%. We will consider percent differences less than 10% as good results that will confirm our theory. If you get percent differences that are greater than 10%, you will need to check your calculations and you may need to repeat part of the experiment.